few more examples of being able to build equations of lines. We're going to go ahead and build the equation that passes through the points -4, 12, and then -2, 18. And remembering that we have our formulas, remember we have our slope-intercept, so our point slope form, excuse me, y minus y1 times m or equals mx minus x1. So y minus y1 equals mx minus x1. And then the other one we have is the slope-intercept, y equals mx plus b. All right. So first of all, with this, we don't have the slope, but we recall that we do have the formula that we can find the slope with. Remember, we have this formula, y2 minus y1 divided by x2 minus x1. So let's just go ahead and find the slope, just like we did a number of times in the previous videos. So we're going to call this x1, y1, and x2, y2. And so our slope m is going to be 18 minus 12 divided by -2 minus a -4. And so the numerator just becomes 6. The denominator is going to become 2. And so our slope is 3. And we're going to hold on to that because now what we can do is we can substitute it back into this formula, our point slope formula. It doesn't matter which of the 2 points we use. My suggestion would just be to use the easier one with the smaller numbers. So I'm just going to use the first one, which is going to be -4, 12, but ultimately it won't matter. So y minus y1, which is 12, is equal to 3x minus a -4. And so now what we're going to do is we're going to go ahead and clean this up. Okay, we could say this y minus 12 equals 3x plus 4. All right, so we're going to hold on to this. All right, and that's one of our answers. And then finally, last thing we're going to do now is we're going to put it into this y equals mx plus b. And so to do that, we're going to distribute. And so if we distribute, we get y minus 12 is equal to 3x plus 12. And then finally, we're going to add 12 to both sides. And that's going to be y equals 3x plus 24. And so we know that the slope of the line is 3. And then the y-intercept is going to be 24 for this line. If for some reason we would have to answer, if for some reason we were asked that. Just really quickly, I want to show you that it doesn't matter which point you use. So let's say, for instance, we use this point, okay, instead. So we would say y minus 18 equals 3 times x minus a -2. And then that would become y minus 18 equals 3x plus 6, because this would become a plus 2. 3 times 2 is 6. And then we would add 18 to both sides. And it would still give us y equals 3x plus 24, no matter what, right? So that's good news that it doesn't matter which of the 2 points we use. It's just easier to use the one that has the smaller numbers in it, if you would, or the numbers closer to 0, if you would. All right. Another example, and this one's probably not going to be as nice as the previous one. So we have the points -1, -5, -7, -10. And again, it might be helpful for you to pause the video and try this on your own at this point to make sure you can find the equation that passes through the 2 points. We're going to start by finding the slope. So that's going to be -10 minus a -5. We're going to divide that by -7 minus a -1. And so the numerator becomes -5. The denominator becomes -6. So we get -5 over -6, or that just turns into +5, 6. Now we're going to have to utilize one of the 2 points, and it doesn't matter which one. We're just going to use this. And so we're going to say y minus a -5 is going to be equal to 5 over 6 x minus a -1. And so we can clean that up, and we get y plus 5 equals 5, 6 x plus 1. Okay, and remember, we're looking for both the slope, the point slope formula, but then also the slope intercept form. And so to finish this off, we're going to distribute. And if we distribute, we get y plus 5 equals 5, 6 x. And this one's easy because we know anytime we multiply by 1, we get the same thing. So it's going to end up being plus 5, 6. And then the last thing we're going to do is we're going to subtract 5 from both sides. All right, so we're going to get y equals, because those 5's cancel out, 5, 6x. And now off to the side, what I'm going to do is I'm going to compute this. So we have 5 over 6 minus 5 over 1. If we get a common denominator of 6, 5 over 6, and to go from 1 to 6, we have to multiply by 6. So 5 times 6 is going to give us 30, and then 5 minus 30 is going to give us negative 25, 6. Okay, and that's going to be our slope intercept. Okay, so the slope m is 5, 6, and then the y-intercept, if we were to ask, this would be negative 25, 6, which means that the point 0, negative 25, 6 falls on that line. Right? So one more of these, and then we'll move on. We want to pass through the point 4, comma 7, and we have a y-intercept of 5. Now, y-intercept of 5 means that the point 0, 5 is going to be on the line. And so what we can do now is we can just go ahead and find the slope by saying this is x1, y1, and then x2, y2. And so the slope m is going to be 5 minus 7, so y2 minus y1, divided by 0 minus 4. And ultimately, that's going to turn into negative 2 over negative 4, or positive 1/2. And so now we can go ahead, we can use this point, or we could use this point, it doesn't matter. Let's use this point because it has a 0 in it. And so that's going to give us y minus 5 equals 1/2 x minus 0, okay? And that's going to be our point slope form, right? But we want the slope intercept form. And so we're just going to go ahead, we're going to distribute the 1/2. We're going to remember that 0 contributes nothing to the solution. And so we're going to say y minus 5 equals 1/2 x. And then finally, we can add 5 to both sides. And we're going to end up with y equals 1/2 x plus 5. And of course that makes sense because the slope m is a half, which we just computed, but the y-intercept is going to be 5, which it better be because we're trying to find the equation of a line that has a y-intercept of 5. And so if it didn't, that means that we were way off base with this. So those are just a few examples of being able to find the equation of lines through a few points. So sometimes we do have to formulate what the slope is going to be before we move on to find the equations. So we have one more video in this section where we're going to finish off the equations of lines. It's probably one of the easier ones. And then we're going to move on to another video series, which is going to tell us a little bit more about the equations of lines.